Okay, with that, I'm going to start today's session. So welcome everyone to day 2 of the FTC Robotics Bootcamp hosted by Team Mecha Mantises 19862. Today we will be going over more in depth into hardware, specifically wheels, drivetrains, intake systems, and outtake systems. And then we will be having a CAD tutorial and yeah.
So first we're going to talk about the different wheels. I know we talked a little bit about this yesterday, but this is just more in depth. The 3 wheels we're going to be talking about is the Mecha wheels, traction wheels, and Omni wheels. There are many other wheels teams could use, but these are just the wheels that we have more experience with. So first with the Mecha wheels, the Mecha wheels can move in all directions, so forward, backward, and sideways, and it has great agility, so it makes quick turns and movements. However, some of the disadvantages of this wheel is that it can't climb over obstacles. And for some season, it is some of your missions might be to climb over obstacles, just like last season, we had to climb over barriers. So keep that in mind. And sometimes it's inefficient in the forward movement. So like sometimes it'll drift. And now let's talk about the traction wheels. The traction wheels, they have good traction or grip, hence its name. And these wheels can move in the direction of the motor it is moving, so which is forward. And the disadvantage about these wheels is that it can't move to the side, which makes the robot a little bit slower, and it's not that good in turning. Lastly are the Omni wheels. The Omni wheels can move sideways because you see on like the screen, there's like black rollers. Yeah, so those are like rollers, which allows the wheel to be able to move sideways. And it could also move forward, obviously. And another advantage about these wheels is that it doesn't have to be attached to a motor to move. So unlike the other two, the Omni wheels don't have to have a motor, and this is because of the little rollers that you see. This wheel has good turning agility, and the only disadvantage of these wheels is that it doesn't have good traction. So usually teams like to kind of combine traction and Omni wheels to form one drivetrain, because like the traction wheels, it has good traction, grip, and the Omni wheels has good like turning ability and a good agility too. So now we're going to move on to the drivetrains.
The different types of drivetrains include 2-wheel drive, 4-wheel drive, 6-wheel drive, 8-wheel drive, and tread drive. The first type of drivetrain, the 2-wheel drive, is recommended only to get comfortable with the robotics parts by first. This type of drivetrain includes the traction and Omni wheel combination, which means that only 2 motors are required to make the robot move. The advantages of this drivetrain is that it is the most simple type of drivetrain to build, and it only uses 2 motors. And the disadvantages of this particular drivetrain is that since only 2 motors are required, this drivetrain is much slower than the others that I've mentioned. Additionally, the traction wheels are only compatible with Tetrix Max motors, which burn out very easily. Also, the 2-wheel drive lacks agility because of its properties, only having 2 motors. Moving on to the 4-wheel drive, which is quite similar to the 2-wheel drive, but the only difference between the two is that the 4-wheel drive has all 4 wheels, even the Omni wheels, that are motored. Some advantages of the 4-wheel drive is that it has a lot of agility, and it has good traction as well. It is also easier to maneuver than the 2-wheel drive, which means it can easily move because all of the wheels are attached to motors. Some disadvantages of this drivetrain is that it tips over easily if another robot is playing defense and isn't as maneuverable as the 6-wheel drive and 8-wheel drive. Next is the 6-wheel drive, which includes 2 corner Omni wheels, 2 drop center wheels, and 2 other wheels in the back. A drop center wheel is the 2 wheels in the middle that are slightly below the other 4, and this allows for better turning, traction, and prevents getting tipped over while playing defense. Some advantages of this drivetrain is that it is hard to build, and the big structure makes this drivetrain very slow. Now moving on to the 8-wheel drive, which is again similar to the 6-wheel drive. However, the only difference is that the 8-wheel drive has 4 of the middle wheels dropped. Some advantages of this drivetrain is that it is stable, it has the most agility, and it has great traction and acceleration. Some disadvantages of this drivetrain is that it is pretty big and a lot of power is needed to power this drivetrain. The last type of drivetrain we will be covering today is the tread drive, which are wheels attached to a tread or belt. Some advantages of this type of drivetrain is that it can run on any texture of ground, has good traction, and it doesn't take up too much power. However, some disadvantages of this drivetrain is that it isn't very fast, it is hard to build, and it is prone to damaging. Now we'll be moving on to the different types of intake systems. The two types of intake systems that are commonly used in FTC are roller-wheeled intake systems and tubing intake systems. In the roller-wheeled intake category, there are a different variety of intake systems, including compliant intake wheel intake, foam wheel intake, and rubber band intake. The compliant wheel intake has wheels that spin, and those wheels are attached to movable claws. Depending on the size of the object the robot is trying to pick up, the compliant wheels intake adjusts itself to fit that object. Now let's move on to the foam wheel intake, which is quite similar to the compliant wheel intake, but the only difference is that the wheels are made of foam. And lastly, the rubber band intake, which is basically a container that is made up of rubber bands so that the robot can intake elements of weird and different objects. This type of intake system is most commonly used with elements that are spheres, and some advantages of all of these type of intake systems is that they are very controllable and they're great for picking up elements that vary in size. But the disadvantages of these types of intake systems is that they can only pick up one element at a time, which makes them inefficient. If the element the robot is trying to pick up isn't in the right position, it can jam the intake mechanisms. Lastly, these intake systems can't pick up elements that are significantly smaller to the container or significantly larger than the container. Now we will be moving on to the tubing intake category, which consists of the surgical tubing intake and the 3D printed intake. The surgical tubing intake is a roller that has surgical tubing attached to it. So as the roller spins, the surgical tubing will be able to intake the object. Next is the 3D printed intake, which is similar to the surgical tubing intake. However, the only difference is that the surgical tubing is replaced by 3D printed parts. Some advantages of the tubing intake systems are that it could collect multiple objects at once, and it is more efficient than the other intake systems that we have went over, and can intake objects of small and weird sizes. Some disadvantages of this type of intake system is that it requires a lot of rotations per minute, or RPM, and you have less control over how many objects you're intaking. Now let's move on to the outtake systems.
So for the outtake systems, we're going to just discuss the linear motion outtake systems. A linear motion is defined as a motion in a straight line, so it just goes up and down. There are many different types of linear motions, but today we'll just be covering rack and pinion, linear actuators, and linear slides. So first, starting off with the rack and pinion. The rack and pinion works by using a gear to move an extended piece. Connected to the extended piece is a rack, and basically the gear has to move up the rack to move the extended piece up. So some advantages about this is that it's reliable, strong, and powered in both directions of movement. So when the gear moves up the rack, it moves the extended piece up. But when the gear moves down the rack, the extended piece moves down. But however, the rack and pinion is bulky and heavy, which can lead to some problems in the tournament. It's not really good to have heavy parts because that makes your robot a little bit slower, which isn't good. So now let's move on to the linear actuator outtake system. The linear actuator works by having a lead screw, and the lead screw works with the metal bar that extends outward. So the lead screw and the metal bar are kind of attached to each other. And when the lead screw spins, so like you guys have seen like a screw, right? Like, so like when it spins, it tightens or loosens, which causes the action for the bolt to go up and down. The many pros of this outtake system includes the most torque, which means the force that causes an object to move along an axis, and it's really reliable and it can move like downwards despite the amount of force that's being put on it. And it's really useful as it can maintain its position under compulsion. One of the biggest cons of the linear actuators is that the linear actuators are very slow, which doesn't help with delivering items in a time limit. So for this reason, it's best to use the linear actuators when power is priority and not speed. The last outtake system we'll be covering today is the linear slides. The linear slides work by using a system of strings that are in a zigzag pattern on the slide. So in the picture, you can see there's a string which are like kind of all over the slides. And when the slides are being pulled, or sorry, the string is being pulled, the stages of the slides will go up to the wanted height. The advantage of this outtake system is that they're really fast, reliable, and they come with many slides depending on how tall you want it to reach. So yeah, they could reach a pretty big height. A big disadvantage of this linear slide is that it could only go up. It can't bring itself down by itself. So for this, you need another mechanism to do this. So yeah, you have to figure out a way to make the linear slide also go back down. And yeah, those are the 3 outtake systems that we covered today. If you have noticed, all these outtake systems just go up and down. That's why they're called linear motions. So the rack and pinion goes up and down by a gear moving up a rack to move an extended piece up and down. And the linear actuator goes up and down by using a lead screw and a long metal rod. And then the linear slide goes up by pulling strings to make the slides or the stages go up and down. So now we're going to move on to CAD and Onshape for the rest of the class.
So Navya, could I please have like share screen?
Yeah.
So as you can see, after creating your Onshape account, you'll want to make a new document, which I'll show you later. And in order to get the CAD parts for FTC, in order to make your CAD, you can go to many different manufacturers. So these are not all of the manufacturers that you can use for FTC, but these are some of the main ones. So let's go over what they each do. So Pitsco creates the parts for FTC under the brand Tetrix. In the website, search up Tetrix and choose the parts and kits that you want. And under every description, you can find the step files, CADs for each of the sizes or types of the part. These are what you import into the CAD software, which is for this tutorial is Onshape. Tetrix parts are usually more lightweight and less durable than other manufacturer parts. So you want to keep that in mind when you're creating the CAD. GoBuilder is another manufacturer that you can buy legal FTC parts from. Like Pitsco, under every description, you will find the CAD for the parts shown. However, GoBuilder downloads these parts as a .zip file, so you actually have to extract it, which I'll show you later on. So Rev Robotics, like Pitsco and GoBuilder, creates FTC legal parts, which you can search up in their website. However, they mainly specialize in sensors and the main parts needed to run the robot. So these include the control hub, the expansion hub, and the driver hub. So now I'll show you where you can go. So these are some of the links. So I'll be mainly using only GoBuilder parts for this demonstration, but you can go to each of the website and see the description. So I'll be making a basic CAD of basically just a motor connected to a wheel. So we'll first find the motor. So GoBuilder offers many different motors, all of which at different RPMs. And so you will find the description when you click on the link, and underneath it, you will find the step file. So just download it. And as you can see, it's a .zip file. So you have to go to File Explorer. And the process is sort of similar on a Mac, but this is a PC. So go to download. And then go to extract all. Extract. And this is it. Okay, so now we go to Onshape. So now and so when you go to the Onshape website, you will find this. So I'm just going to go in. Oh, 1 second. So when you log in, you will find the screen somewhat like this, or like should be pretty similar. So you'll want to go to create and then create a document. So let's say, okay. And when you load up into the actual CAD interface, this is what you should see. So here's your part studio. So like basically any custom parts that you want to make. And then this is your actual like assembly. So where you take all those parts and put it into the assembly. So if I want to import the motor that I just downloaded, you go to import and you go to downloads. And like this, you should. So for motors or any like complex parts that have many like parts that have been put together, if you create a composite part, then when you're like making the CAD and attaching it all together, if you don't like create a composite part for these complex like shapes, CAD will actually separate it out. So for anything complex like a motor, you'll want to create a composite shape. As you can see, upload in progress. And now I'm just going to go Builder to get the other parts needed for this. So a hyperbore is actually what you use to connect like an axle to the wheel. So step file. Extract. Then extract on. Okay, so now I'll go to Onshape for this. So for wheels and like shapes that aren't like made of different parts, you don't necessarily have to make a composite part, but I'm going to do so anyways. And while that is happening, I'll go ahead and import. And it will take a little bit of time for it to show up in your Part Studio, but once it does, you can simply click on it. So this is our motor in this sense. So once you have it load, so let's wait for it to load a little bit. Here's our wheel. Now you want to just press it down like that and check mark it. And so now you have a wheel in CAD. So now if I do that, I can now insert other parts into here. That is interesting. Let me go back to go build out motors. And I'll just read out. I'm 202. And I'll go back to our file explorer, go to downloads, extract all, extract, and I'll re-import this. So once you've gone to like import all of your parts for CAD, for the CAD that you want to create, you can insert it, and then you can connect it in many different ways. So the main part that you want to use, so this is how you like move your parts around. So this little tool. So if you need to ever delete a certain part of this, like here, then you can see okay, now that's done. So this is your fastening, and this is what you're actually going to be using to connect this to the wheel. So basically, if you hover over any sort of like that, you will see like this little target thing come up, and you'll want to come to the wheel here and kind of just hover over it until you find like this target. And so if you saw that little pop up there, so let me go back to insert the motor. So this is a motor. Let's get rid of this. Okay, anyways. So once you have your motor, you can simply attach it using the fasten mate. And going back here, you can attach it to the hyperbolt. And so as you can see here, sometimes it doesn't like translate correctly and it can go inside of other parts. So if you want to maneuver it correctly, what you can do is that you can turn it around and stuff until like it comes correctly. So yeah. I'll now go ahead and click this. And that is basically how you put a motor on a wheel. Thank you for listening to this, and yeah.
Okay, so hopefully everyone got that tutorial and was able to successfully build their intake system. Now we will be moving on to a Kahoot.
Wait, first, does anyone have any questions about was Arya, do you have a question?
Yes. On Onshape, how like he had a problem where he was trying to attach the motor to the yellow thing in the middle of the wheel. So how did you do that again?
So let me reshare my screen again.
So like you move the screen around to get that part.
Wait, so ask your question. Can you
So-
restate your question again?
So my
Go
question was, you took a part of the motor and you attached it to the yellow part of the wheel when you inserted that too, but there you moved the screen. So what was that for? So you said you have to get that piece, so that's the correct piece to attach it to connect it.
Are you asking why I moved the screen around so I could like this, like what I'm doing right now, or what are you
Yeah,
asking?
what you're doing right now when you are trying to connect one piece of the motor to the wheel.
Yeah, so I basically did that because as you can see the mate fastener, you have to get it to a correct sort of place or else it won't basically connect. So it won't always go in the center right there, and it'll click to something else. So you want to keep that in mind.
So you're saying that when you move it around, that box has to appear on the thing that you want to connect it to. So then otherwise it's gonna stick to something else.
Yes. Or sometimes it won't even connect. So does that answer your question?
Yeah, thank you.
Does anyone else have any questions? If you want, you could private message us or just keep it in the chat if you don't want to unmute. Okay.
Someone was having, I know someone was having a problem with extracting a file. Do you get how to do that, or should
yeah. Arya sent me the screenshot. Thank you.
Okay, yeah, no problem. Okay, so now we will be moving on to our Kahoot.
So I'm just gonna paste the link of the Kahoot, or you can look at the digits. So I don't think anybody's using the QR code, but if you are, then just paste it. Just tell me in the chat so I can expand it for you. So I'll wait till 4:33 to start the code. Okay, so it's 4:33. So has anybody not joined? Okay, I don't see. Okay, we joined. So let's begin. Okay, so the answer is mechanism wheel.
Yeah, the picture, it's a mechanism wheel because in the slides, it's like, it was also like a really similar picture to it, but I know that all the wheels are little bit similar to each other. So it's okay if you didn't get it, but yeah, that's how the mechanism wheel looks like.
Okay, so just look at the image. Okay, so it's an 8-wheel drivetrain because if you look at them, there's 8 wheels on it, at least the visible wheels, so 4 on this side and 4 on the other side, so that's why it's 8-wheel drivetrain. But yeah.
Also, one of our team members is also playing along, so you guys could have a little challenge, or never mind, he got kicked out, but yeah.
Okay, so it's outtake. Shreya, would you want to explain this?
Yeah, it's an outtake system. An intake system is on the front of the robot, and it usually has like a claw or like something, but this is just like a linear motion discussed in the slides.
Wow, a lot of movement. Okay, so it is an intake. Shreya, would you explain this?
I think that's my sister.
Yeah, so I think in the slides I went over the 2-wheel intake. It can either be 2 foam wheels or 2 compliant wheels that can move depending on the claw. So yeah, the 2-wheel roller is a type of intake.
Okay, let's continue.
Oh yeah, in the chat you can see that one of our team members is back in the game. So yeah, just try to beat him.
Okay, so this wasn't actually covered, but a sketch is 2D. It is on a plane of a field. It's on just one plane of field, has length and width, but has no height, so it's not 3D. Interesting. Okay, so extruding is where you take a sketch and you make it into a 3D object. These are making a sketch into a 3D image is not correct. It's actually an object, and it's not 4D. So yeah. Okay, so Neil, would you want to explain this?
So the hole feature actually creates like a small hole in your object. It doesn't actually delete. Oh, yeah. So so it doesn't like delete a hole. It just makes a hole, and it doesn't do everything. Yeah.
Okay, so it's supposed to actually be CAD software. So
Arlen, your voice is a little bit soft.
okay, I was trying to say that this is supposed to be different CAD softwares, not just different CAD. Okay, so there's Onshape, Fusion 360, and SolidWorks. There's no such thing as Fusion 460. So yeah. Okay. Oh, there's no image. Okay, my bad. So just select one of the possible outtakes. In this, I did not, there was no image. Okay, so the people who selected rack and pinion, that is also correct. There was no image, but linear slide and rack and pinion are both outtakes. Great. So this is review from yesterday. Okay, everybody got this correct. Good job. It's a base of a robot used to move the robot around. But good job. Okay, let's see. We got third place. Sumed got third place, 7 out of 10. Again, 7 out of 10, Adiant. And Arya, one of our members, got 8 out of 10. Runners up was Dev and Aditya. So good job, guys.
So does anyone have any more questions?
Also, I don't think we went over this, but like for today's homework, can everyone make an Oracle account? If someone could send that in the chat. So basically, this video tells you how to make an Oracle account. We're going to be using that since we're going to be like using the FTC simulator next class. So everyone needs to make an Oracle account in order to install Java 8, and we'll be going over like how to install the FTC simulator. And yeah.
Yeah, we'll also post that video and the homework in the Google Classroom. So it would be really helpful for, if all of you guys could join that.
I sent the link to the Google Classroom in the chat.
Since we have a little bit more time, does anyone have any questions on the Kahoot?
And if no one has any questions, I can walk you through how to make an Oracle account right now, since that would be like, or it's not that complicated, but you need a lot of information, so you should probably bring your parents too.
Why don't you walk them through how to make an Oracle account?
Yeah, I'll do that. Oh, shit. Okay, so if everyone can see my screen. So first we just want to go to oracle.com. Internet is slow today. Okay, and I'm gonna actually sign out first. Alright, so first, so you're at oracle.com and you want to press create an account. Okay, so you need an email address. If you have your own, that would be like good, but if you don't, you would like try to use your parents' email. So first type your email, then you need a password. So your passwords must have an uppercase, lowercase letter, one number, and a special character. So just you can use, if your parents can help you make a password, just have to insert like some of like this information. If you don't want to give your name, you can just put like your first initial or something, your initials. And then job title, you like this stuff you can just ask your parents and they'll like tell you how to like answer this stuff. And yeah, and then you have to create an account, and I'll walk through the rest tomorrow. Does anyone have any questions on that? Okay, so has everyone created an Oracle account? So type in chat or like tell if you have any like questions or problems.
I have some questions.
Yeah.
So, for the Oracle, to make the Oracle account, what should we keep for a job title?
Job title, you can just say anything. You can just say engineer, like student or something. Like
And then for like work phone, company address, anything,
work phone,
right?
you can put your parents' phone number. You can just ask them. Company name, you can again put like student or like school or something, or your school's name, that'll work. Address, if you don't want to give your own address, you can just either type something random if you want to do that. That's what I did, at least. So if you don't want to like reveal your address, or it's better to just ask your parents and they'll tell you what to do.
Okay.
Yeah, I think we'll be ending this meeting a little bit earlier. If you guys have still like have any questions, you could stay, but if you guys don't, then we'll see you tomorrow. for our last class.